Hello and welcome back to another video. In this problem, we're given a table which shows lifetime peptic ulcer rates per 100 population for various family incomes as reported by the National Health Interview Survey. So first, we're asked to make a scatter plot of this data and to decide whether a linear model is appropriate. So right here, we have income, which I'm going to do in terms of thousands. Right? We're going to be doing linear models in the future steps, and tracking a difference in ulcer rate of 1 over $2,000 of income, it's going to be very hard to see, so it's going to be 4 instead of 4,000. So let's graph this. We're going from 4 to 60, so that'll look something like this, up to 60, and so we can do 10, 20, 30, 40, 50. And this is the income in thousands of dollars. On the y-axis, we have the ulcer rate, which is going up to 14. So we can do 15 here, 10, 5. And then we'll have values in between. So now we can graph this. So we have 4 at 14.1. So that'll be right there. 6 at 13.0. 8 at 13.4. 12 on the other side of this 10 marker at 12.5. 16 at 12.0. 20 at 12.4. 30 at 10.5. 45 at 9.4, and 60 at 8.2. And these are just rough estimates of where the points are. All it has to be is close. And we can say, okay, is the rate of change of this data relatively constant? I would say yes. A linear model is appropriate. B, find and graph a linear model using the first and last data points. So our first data point is 4, 14.1. Remember, we're using this in terms of thousands. And our last point is 60, 8.2. So we're doing a linear model. So first we need the slope is equal to the change in y, 8.2 minus 14.1, over the change in x, 60 minus 4. Do this out. This is roughly negative 0.105. Therefore, our function y equals mx plus b is negative 0.105 x plus b. We can now plug in one of our points. 14.1 is equal to negative 0.105 times 4 plus b. B is equal to 14.1 plus this value, negative 0.105, is plus 0.42. Therefore, B is roughly 14.52. For C, we're asked to find and graph the least square regressions line. So this is something that you're not going to want to do by hand. You can do it in a calculator, or there are websites online that can do it. And what you'll find is that it's y is equal to negative 0.1x with a lot of zeros after it before there's anything else. So we just round it to 0.1. Negative 0.1x plus 13.974. And so this is taking into account all of the points. This function, I should write it, y equals negative 0.105x plus 14.52. Make sure you can see that. This only takes into account the 2 points. This takes into account all of the points and wants to reduce the distance between the line and all the points. That's what the least square regressions line is. Both of these have very similar slopes. They just have different y-intercepts. So if we were to graph them, which I don't think is the most helpful thing in the world with this graph, but they're asking for it. We start here at 14.5, here at 13.9 for the intercepts, and they're going to be relatively constant as we go through the data, decreasing slightly, and they're going to look something like that, right? This is part B, this is part C. Again, I think not the most helpful thing, especially for a hand-drawn graph to see, but we have it anyways. So, next, D, we're asked to use the linear model in part C to estimate the ulcer rate for someone with an income of $25,000. So this is Y, the ulcer rate, is equal to negative 0.1 times X is $25,000, so 25, plus 13.974. Negative 0.1 times 25 is negative 2.5 plus 13.974. And adding these together, we get 11.474. This is the ulcer rate expected for an income of $25,000. For E, according to the model, how likely is someone with an income of $80,000 to suffer from peptic ulcers? So according to the same model, y equals negative 0.1x plus 13.974. We have y is equal to negative 0.1 times 80 plus 13.974. This is negative 8 plus 13.974. And this is equal to 5.974. This, however, is not the likelihood. This is the rate. This is actually 5.974 out of 100. So the likelihood is 0.05974. And finally, F, do you think it would be reasonable to apply the model to someone with an income of $200,000? The problem with extrapolating this far outside of the data is it might not necessarily reflect what we're seeing in this range of incomes. So let's just do it for example. Y equals negative 0.1 times 200 plus 13.974. This is equal to negative 20 plus 13.974. And this is equal to negative 6.026. You can't have a negative rate, so therefore no, it is not appropriate. There is eventually going to be some leveling off of this ulcer rate because it can't go negative. Therefore, this model is not actually linear past a certain point and it's not applicable.